Hello, world. That's my little programming. I'm programmed to say that. I have been since the days of the Commodore 64. Basic. That's as far as I got with programming. It's nice to see everybody out there virtually. Don't worry. The only person I can see right now is our guest, Gerardo Dada, field CTO for Catchpoint. And he's right here. And we're both here. It's amazing.
Yep.
And happy to be hosting this conversation on behalf of the new stack. I hope everybody has a tasty beverage out there and you're wearing your professional pajama bottoms in watching wherever you happen to be watching somewhere on this planet, unless, of course, we are being simulcast to Mars. I don't think we are. I don't think we've made it that far yet. But I'm very happy to be doing this today, if only so that I can learn a thing or two. And speaking of learning a thing or two, we've got, a few questions we want to be asking. But if you have a question that comes to mind in the course of this conversation, feel free to ask it. We're going to stack those questions towards the end of this particular broadcast. And this broadcast, for whatever it's worth, will also be available as a download. So you'll be able to watch it after the fact, just so you know. So thank you once again. And let's go ahead and get started because I've understand. Boy, hang on. Let me have another sip of coffee. I understand we have an amazing set of visuals to go along with the questions today, which is great for me because I happen to be a visual learner. And Gerardo, it's very nice to meet you.
It's a pleasure, Chris. Good to see you again. We were talking about the old times and how long we've been spending in technology business and how much has changed in the last 20 plus years. So it's great to be here with you. Thank you.
Yeah, we would have, I think, lightly crossed paths digitally when you were here in the Seattle area. And that was, we could spend this whole hour reminiscing of the way technology was, but the way it is today is a perfect segue to what you're doing at Catchpoint. So you describe yourself as a field CTO. Is there a specific reason why?
Well, so the thing is, I'm responsible for marketing, but nobody wants to hear from a marketer, right? But like you. I started with a Commodore 64 back in the day, learned programming, did assembly language programming, databases, networks, etc. So I've been very technical. So my job as a marketer is to explain technology and to interface with the world and explain how technology fits in today's world. So let's say field CTO is just a claim to say like, hey, please give me a little bit of a benefit of the doubt since I'm a bit more technical than the average marketer. And that's, I'm trying to add value to a conversation, right?
Okay. I envision you somehow in the middle of a field, like a cornfield or something.
It's the field means that travel around and give presentations to customers and work with a lot of CIOs and CTOs. We were talking about Microsoft. I was part of the executive briefing center, and we were talking about things like mobility back in 2005 in the early days of mobile devices and stuff like that. Yeah. So that's why in the field, talking to actual customers, which is a very enjoyable part of my job.
Well, we've made it pretty convenient for this conversation to happen virtually, so no one really has to travel anywhere. Sorry if you love traveling. You just had to travel to a computer screen, right?
Exactly.
So let's go ahead and get the ball rolling here. How has the shift to cloud computing and hybrid IT infrastructure reshaped the role of monitoring in IT operations?
Talking about reminiscing, when I moved back from Seattle, a short while after that, I joined a little company called Rackspace in San Antonio. And they were launching this thing called the cloud. I actually talked to a recruiter at Amazon. They told me they were launching this thing called cloud computing, but the recruiter could not even explain it properly. It's crazy, right? It's only 15 years ago, less than that the cloud became a thing. We had a cloud university to teach people what the cloud is and how you could use it. I remember doing demos to people. Let me create a virtual server. And 5 seconds later, you have a server up and running. And it was mind-boggling. But now everything's on cloud, right? Like it's like today you don't saying cloud computing is like saying I have an electronic computer. Well, is there any other kind? Everything is cloud connected. And the thing is, for every IT department, whether you want it or not, everything is cloud centric today, right? So let me show you a slide. You were talking about visuals. Applications back in the day when I started working for a company, you had a physical closet where you had your servers, you had your Exchange server, you had your file server, you have your networks. Everything was in the building, right? Your application, even you might have Siebel running on premises, right? You had your own, all the systems were in the building. Now the opposite is true. Employees were all distributed. Everything is remote. You might have, in this case, you have an identity server connected remotely. You have remote databases. You have multiple clouds. In fact, good cloud applications that everybody knows nowadays, you need to be multiple availability zones, redundant services in different locations, clusters around the planet, right? So it's crazy. So if you think about, for example, CNN.com is one of the pages that I like showing, because we have a little tool called Web Page Test, which you can use to run a waterfall on any website. So just testing the website, CNN.com, just the homepage flow. This doesn't include anything happens in the back, right? Like all database calls or where they get information or the content management system, 625 different requests. So it gets fonts from one site, it gets an advertising tag from another one, maybe the video from Vidyard or some other site, the graphics from a CDN, a JavaScript from all over the place. So imagine, for loading a page that you expect to load in 3 seconds, 600 different things need to load in that time frame from maybe not 600 locations, but dozens and dozens of different locations working together just to serve a page. And so the point here is that not only everything is internet-centric, but the internet's far more complex and fragile than we like to think. So the way this changes for IT is that now you know, in the past you needed to have a tool to monitor your servers, web server, application server, and database. Then you start monitoring your security, and people build NOCs. Now you need to think about, how am I going to monitor all these dependencies, right? So another visual that I think you liked a lot is this one, right?
Yeah.
So imagine a banking system, right? So if you're a bank, you have things like, look at the top, payment processing. Anybody trying to send money via Venmo, any corporate companies doing Swift, payroll systems, digital banking, people on mobile devices, multiple servers, your branches, your ATMs, your people working in different offices, all your IT systems, your CRM. So all this is dramatic complexity. And to make it even more difficult, like, just think about, I don't know, let's say your Venmo or your Swift. Each one of those little lines has a dependency on DNS. As the joke says, it's
always DNS.
DNS is always a problem. And you depend on the ISP, and you depend on BGP, which is the routing protocol for the internet. So a ton of different things have to happen for this banking system to connect to that API and send the information back. So if you're in IT, one, you need to be aware of this. And second, you need to be on top of things, and you need to be able to respond to anything that happens, because the bank cannot operate unless all these things here are working well. And that's a fundamental shift from the way that IT has been thinking for the last, I don't know, 30 years plus.
It's incredible how interconnected these things are. I mean, if I go to a website and it's not working, I want to blame the website, but it may not be the website that's not working. It's something that it's connecting to, right? To your point.
Correct. And in many cases, those things are dependencies that are not your responsibility, right? You might have a CDN. Well, the CDN is down. It's not my fault. What am I going to do? Well, if you run an e-commerce website, so if you're, let's say you're the CTO or the VP of e-commerce for Target.com or Best Buy, the CEO or the company doesn't care if it's your responsibility or if it's a third-party CDN. And they say, like, the CDN is down. It's like, go find another CDN. And that's why most companies of that size have multiple CDNs. We were just talking to IBM precisely about with NS1 about traffic steering during the Super Bowl. So we are feeding information to NS1 so they can make real-time decisions about a CDN saturation. They were actually working with multiple CDNs, so that when they saw that one of them was getting near capacity, or maybe it was getting expensive, they could actually switch traffic to others or change the balance dynamically as the game progressed.
Wow. I tell you, this kind of leads into the next question, though. how do third-party dependencies like DNS, CDNs, APIs, how do they introduce blind spots in traditional monitoring approaches?
Well, so the thing is, it seems like it's every day you pick up the technology news and you'll see this company's down or this website is down. Sometimes it's even more impactful when you see, I don't know, Southwest canceling all the flights for a day.
Yeah.
Right? 3 years ago, we had Facebook, Instagram, and WhatsApp. Everything went down for about 8 hours. And so the first thing to think about is that it's not if it's going to happen to you or not, right? Like if you might say like, hey, I run a tight ship, I have good systems. Well, it happens to everybody, right? It happens to Amazon, it happens to Microsoft, it happens to Google. We see incidents all over the place. And so the question is not, and those companies have tremendous technology, tremendous quality of people, processes, etc. So the question is not if it's going to happen to you. Is that when is it going to happen? Are you going to have the right systems in place? Are you going to catch things quickly? And so you don't want to be in the news. You want to make sure you're the first to know when something happens. That's critical, right, for these systems. So the thing that happens in monitoring, let me show you another visual, is that all this collection of technologies that are relatively new and people need to pay attention to is what we call the internet stack. So for years we've talked about, there's a technology stack, like there's the 7 layers of OSI for networking, and there's traditional server, like we were talking about, web server, app server, database, and there is the application stack, and there's a lot of dependency mapping nowadays. But now companies need to pay attention to this internet stack, which is, by the way, it's just it's not an authoritative, like this is the entire list of things. It's just an example of things that you need to be aware of, from SaaS applications down to internet core, to protocols, to networks that you want to make sure that you are monitoring, you're paying attention to, right? So all those things in the internet stack. So the incident that happened with Facebook 3 years ago is because there was a change in BGP. So BGP is something that most people don't know about. It's called Border Gateway Protocol. It's the way that networks send packets around the world. So the BGP is like the zip code when you're shipping something in the United States or in other parts of the world. If your zip code is broken, and then you don't get stuff, right? The zip code for companies like Meta, they have their own ASN and their own zip codes. If the BGP routing is broken, they don't get any traffic. So you're not able to access email, you don't access your website, APIs cannot communicate with you. Employees could not get into a data center, right? Because their key cards were not able to authenticate. So it's one of those things that, it didn't seem that important until it happened. And the company lost tens or maybe even hundreds of millions of dollars in revenue because they were not paying attention to BGP, right? And there's not very many companies that can provide BGP information in real time.
Okay. I think that's the linchpin right there. So then what role does synthetic monitoring play in IPM, and how does it differ when performed from cloud data centers versus diverse user-like vantage points?
Well, so the first thing is to understand the value of synthetic. Synthetic monitoring is somewhat like a secret shopper, right? Like imagine you send a secret shopper to a store and they record the experience and they come back and say, you know what, the store was closed. Or they say like, look, everything was fine, but the employee was rude, right? You get a lot of real world information. And by sending a secret shopper, you can do that whenever you want. You don't have to wait wait until you actually get feedback from customers, right? So that's kind of how we explain synthetic in the most simple way. Part of the value of doing that is you can be proactive. So most systems today, they have an error threshold, like typically, let's say 25% error that's when you trigger an alert. And as you know, in monitoring, everybody hates alerts, right? Like alerts, people get too many alerts and they tend to ignore them. So let me show you another graphic that I created that shows, like typically you have like change, like it's in red here on time. And then that change creates problems, and then customers notice a problem, right? So, okay, something's wrong. I cannot perform whatever. Imagine you're a bank. I cannot perform the deposit I'm trying to make, or I cannot send money. And then, so customers are frustrated. And then when they're frustrated, they might actually complain on social media. They might tell their friends. They might think, hey, I need to change to another bank. And then, some of them, as we know, in some cultures is as low as 4%. I think Japan is one of the cultures was lowest. In others is 15% of people will complain. So you complain, you escalate. Okay, now you have the error threshold, either because of the system of people. And so, okay, you're detected. IT starts working on it. Okay, we fix it. And now you have like the resolution, right? And that mountain, which is savings actually right now is a problem. Sorry, wrong label. But now imagine you're actually testing this proactively. Every 5 minutes, you're sending your secret shopper to simulate that transaction on the bank from multiple locations, right? So you are proactively, you detect the issue as soon as it happens. The detection is much faster. You have the ability to fix it if you can get to the root cause, and then you solve it. So your mountain of incident is that little blue hill rather than the gray mountain. So all the gray stuff is all the impact that you're saving, right? So that is the impact of proactive monitoring, of using synthetics. Now, a lot of companies use synthetics. They're all over the place. What's really important is that a lot of synthetic technologies deploy their agents that do the secret shopping in the cloud, right? So you're in Seattle, there's a data center there from Amazon. You deploy an agent there, and from the cloud, you're testing a website or a mobile transaction. Well, the thing is, as you and I know, a data center in the cloud has tremendous capacity, networking, throughput, different servers, etc. Very different experience than what I get, or different network capability than what I have in my phone connected to a wireless network that might or might not work properly, right?
Just a bit.
So your customers are not in the cloud, and you need to know what is the real world experience as the first thing. And the second thing is that experiences change by region, right? So we were talking about we're using multiple CDNs. Many of our customers, we sell to many retailers, they actually try and test and benchmark their CDNs in different parts of the world. We publish a report on Gen AI tools, right? So if everybody's building AI, everything, right? So you're using Copilot or Gemini or whatever via an API, your system now rely on that API. Well, it turns out that the response time of those APIs from Seattle, where you are, from Austin, where I am, or from your employees in Europe, or other parts of the world, it changes dramatically, not only by region, but by region and over time. So it is important to measure from where it matters. That's what we say. You need to monitor from the locations that matter. If you're a luxury retailer, right? So if you're Porsche, the auto manufacturer, or Louis Vuitton, likely China is going to be your most important market. With a great firewall of China, most companies, or I would say, I don't think of any big company that actually does synthetic monitoring from inside China. We have 100 different agents in China. So we can tell you what is the experience of somebody in Shanghai versus somebody that is in another city. I don't know many cities in China, but somebody in a mobile device versus somebody that is connected through a different ISP, maybe China Mobilecom, versus somebody connected through Alibaba, versus maybe even connecting to a cloud node inside one of the cloud, Tencent cloud over there, and what is the connectivity back to the United States or wherever your servers are. So being able to understand the impact of those systems is critical, especially even today from a security perspective. Most companies are implementing SASE, right? Zero Trust Network Access and different remote access technologies. You need to understand what is the impact to your users of those technologies in each region. Because it might work fine if you're a Seattle-based company in Seattle, but if people in Austin, I connect through Spectrum. I used to have AT&T before. There are very significant difference between the two, and there are things that change all the time, like routing protocols, ISP performance, the configuration of those SASE providers, etc. So being able to react from those geographies and be aware of what's really happening in the real world is critical.
So then, what unique metrics or insights does IPM provide that are crucial for managing the, if you will, what you described, the internet stack?
Yeah, so the one thing that is really critical here is understanding what is the actual experience. Because for years, we've been monitoring systems at the system level, obviously, right? So I used to sell database performance monitoring technologies when I was at SolarWinds, and we talked about wait time analytics inside a SQL Server, right? And we can tell you like your SQL queries are running this fast, or there's this much wait time in your databases. And so you can also tell on the cloud monitoring space, when I was at Rackspace, we could say like, look, this is the CPU utilization of your cloud servers, or this is the memory thresholds that you're reaching if you have a VMware cluster with VROPs or whatever else you're using. Now, that's useful information. I'm not saying it is not. But what really matters is what is the actual experience you're delivering to your users, right? If you're a bank, you care about the mobile user trying to complete a transaction, as well as the teller that is in the bank trying to serve customers. Like it's almost a joke that every time you rent a car, you go to the counter and there's always a line, and they always say, "Sorry, my computer is slow." Right? So that impacts the business and impacts profitability and impacts loyalty and impacts trust. So what really matters at the end of the day is the experience of your application. What is experience to the either internal user, external user, customer, or even a system, an API, right? Like today with the Internet of Things and systems communicating through APIs and Gen AI, the experience you're delivering to another system or to another user is critical. So as an example, let me show you another slide. We have this thing that we developed called the experience score. So the experience score, you say, look, it's not that we don't care about what is the CPU performance, just great, and the database wait times important, but I want to know, how is my team in Dallas able to produce, right? Imagine you're in a lawyer office. We have offices in Dallas, New York, Chicago, etc. I want to make sure those teams can actually do their job. And you can actually see experience scores by geography, by team, by individual. We deploy agents inside, end user laptops or desktops, where we actually monitor the actual computer and their experience. And so instead of saying, look, CPU utilization went from 75 to 85, and as an IT guy, like, do I care? Do I need to do anything? Well, if you look at this dashboard, look, you need to pay attention to London. There's something going on in London where the experience is bad, and your users are either complaining or frustrated or not productive or all of the above. So that's what you need to pay attention to. And then from there, then you're able to look at, okay, what is causing that experience? Is it the network? Is it the application? Is it an API? Is it a provider, etc.? And then you can quickly solve the problem. So it actually points you to where you need to go versus just looking at a bunch of system metrics.
So then how do IPM and APM work together to create a more comprehensive monitoring strategy for resilient digital experiences?
Yeah, it's a great question, because IPM is part of observability, and a lot of people understand that they have APM, and a lot of companies have NPM. And so what's important is to understand what is the information you're getting from those systems, right? So NPM is going to tell you about your local networks and about traffic. APM is going to tell you mostly about the application, right? And so even the synthetics they do are great for monitoring the performance of new code. So it's almost like a QA process. It's okay to do that from the cloud. But the focus of application performance monitoring is really application logs, code traces, and infrastructure metrics, right? Or also event, like now there's this acronym called MELT. IPM looks at experiences. What is the health of the global internet? What is the experience of your employees? So the idea is that now you have NPM, APM, and IPM, all the three of them working together. So we put a special care into exporting our data, making it available through OpenTelemetry. We can consume data from your agents inside code and show traces as part of the IPM, but also export our data to other systems, or big companies use things like Databricks or other data systems to collect and monitor systems. But the idea is that the majority of large mature companies are using APM and IPM together to get the best visibility they need into their systems. So you can see both the end user experience, the internet visibility, and also your internal visibility into your technology and your application, your code. It's like in your car. You have a dashboard that will tell you what is the RPM, and the gas capacity of your tank, and some other systems that are your system metrics. And then you have your GPS dashboard that's going to tell you where are you going, when are you going to get there, and are there incidents that you might want to take a different location, a different route to get there.
Now, speaking then of kind of working together to create a better experience, as the internet becomes more integral to business operations, what steps can companies take to align IT monitoring strategies with business goals like customer satisfaction and operational resilience?
Well, so the first thing that I think it's very interesting for a lot of these businesses is to think about the idea that all your interactions are digital today, right? So let me show you a graphic that shows like what we call a dock. So people have a NOC, a network operations center, and they created now a SOC, security operations center. I think companies need to build a dock, a digital operations center. So this basically tells you how is our business working as a digital system, right? If you're a bank, like my mobile applications, my ATMs, my internal people, my traders, my people in my offices, HR department, etc., you want to make sure that all the digital systems that are essential for your business to work are operating well, right? So you want to see that dashboard with all greens. And we see this at some of our customers. It's amazing. I don't know that I can mention the names, but we walked into some of these operation centers that look like the National Mission Control, and their main screen at the center is a Catchpoint system like this that shows you what is green and what is red and what needs attention. And from there, you can look at, okay, let's look at the network and let's look at databases, let's look at applications, etc. So that's the first thing I think it's important for customers. The second thing is to think about, let me show you something else, is to think about different metrics that you should be thinking about. So there is traditionally, most businesses operate on this concept of SLAs, right? So you have an SLA for different systems, and nowadays you want to, those SLAs are actually giving you a performance of specific parts of the system itself, right? So it's not showing you the actual user experience. And so the business cares about the user experience. IT seems to care about system metrics, right? So now imagine a system where you can actually adopt user metrics as your end goals. So that's what we call XLOs, experience level objectives. So then imagine if your SLA, instead of saying, you know, my system needs to be able to operate at 70% CPU utilization again, you say, like, I want to make sure that my users in any of the top 20 cities in the United States can complete a transaction within 10 seconds. I want to make sure that everywhere where we have a rental car location, our agents are able to pull out a reservation and submit it and get it responded within 4 seconds, right? So that's an experience level objective. And that basically puts the end user at the front of the system. And that means that what IT is striving for, which is, I want to make sure that the IT systems in this rental car company are supporting the experience that we deliver to customers, supporting the business. That's the same objective from the business and from IT. And any improvements you make to the IT systems will be improvements that will apply, you will be able to show as how you're meeting or exceeding those experience level objectives.
Okay. So then if you could break it down for me, what's the primary difference between digital experience monitoring, or DEM, and internet performance monitoring, or IPM, and how do those tools complement application performance monitoring, or APM?
Yeah. So digital experience monitoring is kind of there's different ways to think about it, right? But if you think, like, most APM systems offer some level of digital experience monitoring because it's so important. Gartner research published for the first time the Magic Quadrant for digital experience monitoring just a few months ago, recognizing that it's so important. But in the same report, they said, well, there's also this thing called internet performance monitoring, which is basically, well, let me step back. Digital experience monitoring is the ability to use things like synthetic monitoring or ROM technologies or other systems to understand that experience you're delivering to customers. Internet performance monitoring expands that definition to say, yes, but you need to monitor from what your users are. And second, you need to understand all the impact of anything in the internet that is impacting that user experience. So it's not only useful to say, hey, your website is down, your customers in in Seattle cannot access your website, you want to know why. You want to know what is causing that problem and how you can solve it, right? So it's not enough to say your API has a higher response time than what we want. You want to know, is that a routing issue? Is that a response time issue? Is there something inside the database that we need to go fix? Like that is the main difference between DEM and IPM. There are very few companies that can do IPM properly, precisely because of the need to have this geographical view. So let me show you, for example, we have a network of intelligent agents around the world. We have almost 3,000 intelligent agents. So I was talking about 100 of them in China. We support over 100 different countries. We support, we have over 1,500 different BGP peers, different locations, different providers. And that's what makes becoming an IPM provider really difficult, is that you need to have all this global presence, not only geographically distributed, but also inside the cloud, inside the backbone of the internet, in last miles. We can even monitor Starlink performance, right? So we have nodes that are using Starlink so that we can show you what is the satellite connectivity. We haven't gone to Mars yet, but who knows? It might be
next week. Now, can you provide examples of real-world incidents where IPM helped resolve performance or resilience issues faster than traditional tools?
Yeah, so let me start with one we call workforce experience. We were dealing with let me pick, there's a technology company that sells a lot of computers, and their Salesforce was complaining all the time, hey, I'm connecting to salesforce.com, or I'm using different applications or entering my orders, and I'm frustrated. Like Gartner research says that there's a tremendous amount of frustration. They call it digital friction. It's something like 80% of employees suffer from digital friction, significant digital friction on a weekly basis. So it's typical that they were getting complaints and IT was saying it must be user error. So there was impact on the trust of the employees. There was impact on their productivity. There was impact also on the trust between IT and the users, and the productivity of those salespeople. And they've been trying to solve this problem for a long time. They deployed Catchpoint, and they found that there were some incidents in the applications and the ISPs that were using. And they were able to catch those incidents within minutes and solve it. And now you have thousands of sellers who are not only happier at their jobs, but they actually can save 10 minutes a day. Now multiply 10 minutes a day of saving time times 5,000 employees times 300 days a year. It's significant savings from a workforce experience. We're also working with Sony PlayStation. One of the biggest markets is in the Middle East, and they were having an incident, and their customers were complaining, and they could not figure out why were customers complaining. They said, we've tried every monitoring tool, everything looks green on my side, and yet customers are complaining. Right? That's a great indication that you need IPM. All my systems are green. All my monitoring tools say that everything's fine, and yet my entire set of customers is frustrated in this particular region of the world. They install Catchpoint, and within minutes, we showed them that there was a component of their application that they had hard-coded to route traffic to Germany. So instead of using the local CDN or the local servers, traffic was going all over the world to get to what it needs to go. And in gaming, latency is very critical, right? So you want to make sure that you're aware of those systems. And from that point, Sony has been now using Catchpoint extensively, and their customers are happier. Forrester research shows that the companies using IPM have fewer incidents, and they save money, and they deliver better experience to users. We're happy to share that report with anybody who cares. It's on our website.
So you're making the case, clearly, but we're all being asked to cut costs and consolidate tools. How can we convince leadership we need an IPM platform added to the tech stack?
Well, the first thing is that we do a lot of consolidation, right? So there's a lot of companies who are using legacy tools, and we have a program to help migrate scripts and upgrade their monitoring. In many cases, monitoring with Catchpoint can be cheaper than some of the alternatives. But the more important cost is, what is the cost for your trust with your users, and what is the cost of your of the war rooms, right? So if you're not doing proper monitoring, every time there's an incident, you typically call a war room, and that costs a ton of time of your best people who need to pay attention to, hey, what's broken? And it's like triage, right? Going one by one of the systems to try to find the problem, the needle in the haystack. That costs a lot of time and effort from an IT department as well. So that's the first part. And the second point is that when you can find a problem quickly and deliver a better experience, it's better for the business in general.
So everyone's talking about AI. How can AI-driven insights, such as those provided by tools like Internet Sonar, enhance root cause analysis and resolution times?
Yeah, so that's always, well, we've been doing AI for maybe over 10 years. So let me show you. We have this thing called Sonar, which we have a free version on the website. Everybody can go to catchpoint.com/outages. And what I'm showing right now is the live outages. We have a weather service, Asana, Cheap Flights, Salesforce, and Hulu, all down in different places. So we run billions of tests a day for hundreds and hundreds of services, separate from the tests that our customers want us to run for them, just to get a general health of the internet. So we use AI because you don't want to alert people for every single little thing that is happening, right? So you want to use AI to say, like, is this actually a trend? Is it happening multiple times? Is that one failure enough to create an alert, or do we wait until we have more? So we correlate and consolidate all this information. Let me show you something else. There's this other chart that I want to show you that is called Stack Map. So Stack Map uses correlation and trend analysis to actually detect what is the right what is the cost, the root cause of a problem. So in this case, what I'm showing right now is a application dependency map that shows not the traditional dependency map, which again is focused on the system, which is code to code. This is actually from the end user, origin servers, DNS, cloud providers, applications, APIs, all the way to the back end, to database and to servers using tracing. So using AI, first, we create this map. Second, we normalize the data. We identify trends that require attention. And then we identify what is the root cause that requires where you need to pay attention to solve a problem, right? So you can then drill down and do everything you want, but this is a good example of AI. Yet another one that we have that I particularly like is on the web page test technology that I was talking about. We do this thing, I showed the CNN example with the 600 different things. We have AI that detects, like, we think there are these experiments that we want to run. There are opportunities to improve the performance. So we actually, with AI, generate experiments that simulate, basically clone the website, make the changes that we think are going to improve the performance, run our tests again, and we can show you, hey, we think by deferring JavaScript, this JavaScript line, or by optimizing your website, you can improve performance. But let me test it. We actually test it and we tell you, yes, it did work. Or you can test a combination of steps. So now you have the certainty that the changes you're recommending actually will make a difference for the end users.
Well, this is certainly, I love having these types of conversations because I get a chance to learn a little more about how they say you never want to know how the sausage is made, but how the sausage is made. And so, I certainly appreciate the insight, and I know people who've tuned in appreciate what Catchpoint, is or can provide for them. So we're going to start winding down here, but I did want to ask like one last question here, unless there's any that have come in from the viewers that I feel has not yet been covered. What should organizations look for in an IPM platform to ensure robust visibility and performance management?
Well, they should look at three things. One is that you need to monitor from where it matters, right? Where your users are. Again, users could be employees, customers, or digital systems consuming an API. Second, you need to monitor what matters. What matters is things from BGP to your CDN to ISPs to APIs to your own internal networks. And by the way, there's a question about monitoring cloud services like AWS. The Sonar graphic that I was showing you actually monitors those cloud services in real time, so that you can be aware when, I don't know, AWS Compute East is down, for example. So that's monitoring what matters. You can monitor inside peer-to-peer connectivity between two network clouds. You can monitor from your systems to the cloud, all those kind of things. So monitoring what matters. And the last one is get to the answer faster, right? Use all the tools and the metrics and the right systems so that whenever you detect an incident, you can react quickly and get to the answer, meaning solve the problem, ideally before your users are impacted.
You know, Gerardo, like I said, it's fascinating to me. This is like beyond, I'm the user. I'm the one going to the website or using the services going, it's not working. So I, on behalf of all the users on the world, need companies to use Catchpoint, because I don't want to mess with downtime. Who wants that? No one's got time for downtime. Nobody.
Yeah. Every business now relies on the internet, right? We like to say the internet relies on Catchpoint. That's why all the cloud providers, Amazon, Google, Azure, they all use Catchpoint. The 7 of the top 10 digital companies, the top software companies in the world use Catchpoint. Every CDN on the planet uses Catchpoint. A lot of the ISPs, every commerce platform from SAP Commerce, Salesforce Commerce, Shopify. Because it's essential, right? It's not optional anymore. It's not this one thing that it is cool and interesting. It is essential. If your business is digital and your users are digital, which I would argue pretty much every business is, then you need to pay attention to internet performance monitoring before you show up in the news, right?
Yeah, you can't just look out the window and say, well, it's sunny here, so what's the problem?
Yeah, exactly. That's a good analogy.
And it is sunny in Seattle today for whatever it's worth. It's an anomaly. I don't know. First day of spring, fake spring. I don't know exactly what's going on. Well, anyway, thanks again for your time, your expertise, and taking the time to have this conversation with us.
Thank you, Chris. It was fun. I appreciate your time and all the questions.
I appreciate the visuals. I genuinely do. Like it's all in the head.
I'm a visual person always.
Yeah.
Love whiteboarding sessions and stuff like that.
Yeah. Big time. So, again, on behalf of the New Stack, really appreciate you being here and doing this. Everybody, this will be available if you're watching live as a download after the fact. If you're watching the download, well, you're watching the download. So, hey, it's a good thing. Thanks again, everybody, and we'll catch you the next time.
Thanks, Chris. Thanks, everybody.
Thank you.